Okay, so I need one big whole page from you, please, and I want you to split it into one big Cartesian plane. So this, I'm going to zoom all the way out. Okay, well, that's as far as I can go. So if that is my page, I'm going to do one very big Cartesian plane. Thank you. Okay, so one very big Cartesian plane, please. And just like our usual Cartesian planes that we are used to, my horizontal line is x, my vertical line is y. We are going to do, yesterday when we ended the lesson, we landed up with a triangle in my first quadrant. So that's the first thing we're going to do, is we're going to note the quadrant numbers. Quadrant 1 is where both x and y are positive. So this is my quadrant 1, and I use Roman numerals. Going anti-clockwise, my second quadrant, my third quadrant at the bottom, and my fourth quadrant at the bottom. So that is what it looks like currently. Quadrant 1, 2, 3, and 4. Now we're going to do what we did yesterday in each of my quadrants. Okay? So I'm going to use the same values. I'm going to do a new one. I'm going to do in each quadrant, I'm going to use a new color, starting with green, but you don't have to. It's not the end of the world. So the first point that I'm going to give you, so I'm zooming in only into quadrant 1 now, so I'm going to zoom in. Giving you the point P, which is, let's go 6 and 8. So what we will do then is connect the point to my origin. Forming a 90-degree triangle with the x-axis. So my x value is equal to, and my y value, and I still need the hypotenuse of that triangle, and I would do that by Pythagoras. So we agreed that my x value lay here, my y value lay here, and on a separate page you can calculate Pythagoras, but I'm going to tell you that it is 10. And that is my R value. Theta is the positive angle from the x-axis to the point where it meets the line. So it's a positive theta value. Yes, Aaron? 5 past 1. So this is the last period for the day. Okay. So if that is theta, is x or y my opposite value? Y is my opposite. So if I had to do all three of my trig ratios, sine, theta, tan, theta, cos, theta, opposite y over hypotenuse r. Tan opposite is y over adjacent x. And cos is adjacent x over r. So right now I'm not too interested in the numbers, but we will fill them in. So it would be 8 over 10, leave it in unsimplified form. 8 over 6 and 6 over 10. So 8 over 10, 8 over 6 and 6 over 10. Moving to my second quadrant. I'm going to use the same numbers, but now can my x value still be positive 6? What will it be now? Negative 6. Can my y value be the same? Look very carefully where my 90 degree is formed. We now have negative 6 for my x, still positive 8 for my y, and on my calculator I'm tricking what my hypotenuse would be. It would be the square root of 8 squared plus negative 6, close the bracket, squared. I still get a value of 10 for my r. Now I said that my theta is always calculated from my x-axis to the point that it meets the line. So my new pink theta would look like that. Therefore, which is opposite that pink theta, x or y? It is still my y value. So we would say sine theta, I'll keep the order that we had before. So opposite is y, hypotenuse is r. Tan opposite is y, adjacent is x, and cos adjacent is x, and hypotenuse is r. So my ratios haven't changed, right? The letters x, y, r are still the same. Let's fill in those numbers. Y is still 8. Hypotenuse is still 10. Y is still 8. But my x is now negative 6. And my x, negative 6. My hypotenuse still positive 10. Giving you 1 minute, and then I'm moving on to my third quadrant. Functions and trig. 33 marks function, 17 marks trig. But no trig functions. So no graph, so nothing about investigation 2. Nothing about that. Okay, I'm moving on to my third quadrant using the same 6 and 8. Okay, third quadrant. Can I still have a positive 6 for x?
Yes.
Where am I in my x-axis? I'm still in the negative, but now what about y? Also negative. Okay, so with my point to my origin, watch how I've formed my 90 degree. My 90 degrees always with the x-axis, never the y-axis. So my x is still negative 6. I don't have to rewrite it. My y is negative 8. What do you think my hypotenuse is going to be? Who says negative 10? Who says positive 10? Do Pythagoras on your calculator and tell me what it is. Remember, we have negative 6 squared and negative 8 squared. Positive 10. Remember, a negative squared is always positive, so it doesn't matter that the x and y are negative. My hypotenuse will be a positive value. So showing it to you, square root. Negative 8 squared plus negative 6 squared still gives me positive 10. So let's write down our trig ratios, sine, tan, and cos. And I said to you, my angle is always going from here all the way around until I touch the line. So now I have an orange theta. That means opposite my theta is still y. My r is still my hypotenuse. My x is still my adjacent. So my ratios still have not changed. It is still y over r, y over x, and x over r. Let's put in those numbers. Y is negative 8, r is positive 10. Tan, I have negative 8 over negative 6, which is positive 8 over 6. And cos, I have negative 6 over positive 10. And we're going to do it for my last quadrant. So I've just identified the 4 different P's because they're obviously not all exactly the same point. So I'm just making P with 3 lines because that's my 4th P. If I still want to use 6 and 8, is my x still going to be positive or is it going to become negative? My x is positive, but my y is negative. And my 90 degree is formed with the x-axis. I kind of drew that one a bit skewed. That would mean this is negative 8, but it is my y value, positive 6, but it is my x value, and Pythagoras tells me that it is still positive 10. So one more time I can do my ratios. Sine theta, tan theta, and cos theta. Now please look at what I'm about to do. Measuring my angle from my x-axis all the way around to the line that I meet. So that makes y still the opposite. X is my adjacent and my r is still my hypotenuse. So y over r, y over x, and x over r. Putting in those values, negative 8 over 10, tan would be negative 8 over 6, and cos would be 6 over 10. Yes, Rebecca?
Ma'am, do we have to simplify the fractions?
No. At least not from this. So now you have seen what I could ask you in any quadrant. And you can see that you still can find sine, cos, and tan ratios. And you always find your radius using the hypotenuse. Now there are some very key points of information. First thing, my angle that I measured is always from the x-axis going anti-clockwise to be a positive angle. So that's the first thing. Going that way is positive. Now I want you to look at sine, cos, and tan in terms of are they positive or negative in quadrant 1. So going back to quadrant 1, sine, cos, and tan, positive or negative? All three are positive, right? So just for the time being, I'm going to write the letter A for all. Look at quadrant 2. Which one is positive? And the other two? Negative. I'm going to write the letter S. Sine is positive. What about quadrant 3? Tan is positive, so I'm going to write the letter T. Zooming out of it. And my fourth quadrant, cos is positive. And we refer to this as the cast diagram. C-A-S-T. All functions positive. Sine only positive. Tan only positive. And cos only positive. So the cast diagram refers to which function is positive in which quadrant. So if I asked you in which quadrants is tan positive, which quadrants would you tell me? 1 and 3. What about cos? Where's cos positive? 1 and 4. 1 and 4. Where is sine negative? 3 and 4. Where are all three positive? In 1. Now I'm going to add to it. Where is cos and sine negative? in 3? Where is tan and sine negative? In 4. Now listen very carefully, adding even more to it. Where is sine and tan positive? So I'm only looking for sine and tan to be positive. So it would be 1 is the only place where they can be positive together. Okay? Now, before we move on to some notes, we can also assign degrees, right? So if I went from my x-axis to my y-axis, how many degrees have I moved through? 90 degrees. If I move from my x-axis, which I'm assigning 0, and I move all the way around to the other side of my x-axis, how far have I moved? 180. From 180, going from 0 all the way around to the vertical, 270. And if I had to go from 0 all the way around and touch 0 again, it would also be 360. Can I take this off the screen? Okay, so just a quick recap. Quadrant 1, 2, 3, and 4. Sine, I want you to tell me, is it positive or negative? Cos, positive or negative? And tan, positive or negative? Okay, so quadrant 1, we know that sine is positive, cos is positive, and tan is positive. In quadrant 2, we know sine is the only positive. Quadrant 3, we know tan is the only positive. And in quadrant 4, we know cos is the only positive. Therefore, the rest have to be negative. So I can make it a little bit more difficult. So the questions that I asked you now, we're going to start off again. So if I ask you quadrant questions, I want you to draw just a quick little quadrant, mark off according to what I've asked you, and where the all criteria meet is my answer. So let's start with an example. So where would I find tan theta negative? Well, we know we went through it, okay? And we can see that even in this summary that we've done, tan is negative in 2 and 4, okay? If I had to draw it on a little cast diagram, so I would say cast so that I can remember which is which. Well, I want tan, that's positive, so tan would be negative there and there. So I would say, therefore, 2 and 4. That's easy peasy, but obviously it's not going to stay that easy peasy. Let's look at another one, where tan theta and cos theta are both negative. Okay? So tan theta and cos theta are both negative. Drawing my little cos diagram. I want cos negative, so I'm going to look at cos. Well, I know cos is negative there and there. And I want tan negative. Well, I know tan is negative there and there. So the only one that has both of them is in quadrant 2. If you had to look at your little summary table, we're looking for cos negative, those two, tan negative, those two. So quadrant 2 is the only one that fits both criteria. Going to go one more step difficult. I want to know where tan theta times sine theta is negative. Now what? Because I know that a positive and a negative times together is still negative. Okay? But now we need to look at every combination of how that can occur. It can occur when tan is positive but sine is negative, and it can occur when sine is positive and tan is negative. So what I suggest is that you do all of them. So we know that sine positive, tan positive, sine positive, tan negative, tan positive, sine negative, and tan negative, sine negative. Now the only way to get a negative is positive times negative equals negative. So I'm looking for a combination of positive and negative together. Positive and positive, not going to happen. Negative and negative, not going to happen. So it's positive and negative and negative and positive. So therefore, quadrants 2 and 3. Let's see if our little summary table can also make it a little bit easier for us. So I'm looking for sine and tan having opposite signs in the same quadrant. Opposite signs, same quadrant, so quadrant 2. Quadrant 3, they have opposite signs. Quadrant 4, they have the same signs. So 2 and 3 are my answer. Yes, you can. So it is once again matching that criteria. So I'm going to ask you as an exercise, so just take that so you can still copy that. Find the quadrants using either the table or a little cast diagram where sine theta times cos theta is greater than 0. Greater than 0 means positive. So I'm looking for where two quadrants where I multiply sine and theta, cos and theta, no, cos and sine together, giving me a positive answer. Yes. Yes. I'm just looking for something Mrs. Mann sent us. Who's still busy? Give you a moment. Okay, then. So, in order for something to be positive after a multiplication, what do we know that we need? Two positives or two negatives. Okay, so a positive times a positive or a negative times a negative. So what I've done is I've gone and written where cos and sine are positive, and now I'm looking for where the signs are the same, positive, positive, or negative, negative. So there's positive, positive, so the multiplication would still be positive. There's negative, negative, so the multiplication would still be positive. Therefore, quadrants 1 and 3. Now I have one more. And it's going to take some thinking. So I want to know in which quadrant, so can I move this up? Will I find sine negative theta? And all I know about theta is that it is less than 90 degrees. So I remind you that everything we have been measuring has been positive and anti-clockwise. I'm going to go back to my Cartesian plane. If everything I measured anti-clockwise was positive, what would I be measuring if I went clockwise? So I'm changing my direction, Jed. Pardon? Yes, it would be in quadrant force, but that was the question, answer to the question on the paper. The answer to the question that I asked verbally is that if it is anti-clockwise for positive, it would be clockwise for negative. So if I said it was smaller than 90 degrees, well then it can't go anywhere but there, right? Which would be quadrant 4. So my answer is quadrant 4. So that brings me to negative angles. So do you think you'd be fine if I had to ask you some of those kinds of questions? So just mark off on your Cartesian plane and circle the quadrants that match the criteria. I am going to give you a worksheet to practice later in the week, which does all of this as well. Okay, negative angles. Negative angles are measured in a clockwise fashion from my positive x-axis. So just to remind ourselves, that means we're going in that direction. So the negative tells me the direction in which I am moving. So whether we measure positive or negative, we can get to the same point on my Cartesian plane. So we can get to the same point on my of my Cartesian plane. Because the positive angle and the negative angle together would make up what? So if I want to get to exactly the same place and I ask you to measure it in a positive fashion, so let's say I wanted to get there, measuring positive, we would go from here to there, right? That would be positive theta. Now if I was measuring in the negative direction, let's do it in green, I would go from here to there, the negative telling me the direction, but it won't necessarily be theta, so I'm going to call it a different angle. So what can you tell me about theta and beta together? It's a revolution. So B, the negative and the positive together must make up 360 degrees if it is going to the same place. So the positive theta with the negative beta equals 360 degrees if they are going to the same point. So as an example, there's my Cartesian plane. Oh, you can't see it. I'm going to this point in my fourth quadrant. I'm telling you that theta is 320 degrees. I want to know the size of this angle here. So if the positive angle makes 320 and it's meeting at the same point, the beta angle has to be, so measuring in the negative direction, so that's where my negative is. So the negative is not negative in terms of positive and negative, it's telling me the direction. Like you get in physics, negative means the opposite direction. That is what it's meaning here. Okay? So what would the value be? What would the number be? 60 degrees. Would it be 60? 40 degrees, because it must make up 360 degrees. So if I was measuring cos, for instance, cos of 320 degrees has to be the same of cos negative 40 degrees. So very important, the negative tells you the direction. Now if I went to the negative quadrant, the first quadrant 4, would my cos be positive or negative? But remember your cos diagram. So even if I had a negative angle, cos negative 40, my answer is still going to be positive because it is positive in that quadrant. What would sine be? Negative. And tan? negative. So we can actually write a little bit of a summary. In quadrant 4, cos negative theta, I can measure the positive angle, but it'll still be positive because of where it is in the quadrant. So I can take the value of theta and it will still be a positive value. Sine of negative theta, well, if I had positive sine, it would still be positive, right? If I take a negative sine, it's in my fourth quadrant, it will become negative. And I can use that exact same angle but put the negative out in front of my function. And same with tan. And this will become a little bit more clearer once we actually do the functions as to why I can take the number 40 as my angle, even though it is actually 320, for instance. Why is it that 320 and 40 have the same answer? But we'll do that when we do functions. Right now, just remember those things. I'm going to use the full time, so we still have 7 minutes. There's one more thing that I had scheduled for us to do today, else we are going to fall behind. Actually, 2 more things, but we'll only do one of them. Is what happens when I have an angle that's greater than 360 degrees. So I'm just going to turn a new page. I'll move that to the top. Angles greater than 360 degrees. So when it is greater than 360 degrees, we're going all the way around and we start again. So we are surpassing 360, sorry. We reset our ratios. So for example, let's just say sine 360 degrees plus theta is equal to just saying, well, we reset, so it's just sine theta. So we're going to look at an example. And that would be the same with cos and the same with tan. Cos 360 degrees plus theta, we reset the 360 and just take the theta. Tan 360 degrees plus theta, reset the theta, and reset the 360 and just take the theta. But when I give you to an example, that is the kind of example that I would give you. Tan 400, and I want you to simplify. So what am I adding to 360 to get to 400? So I can say tan 360 degrees plus 40. That means I can reset to tan 40. So tan 400 is the same as tan 40.
Attention please, downstairs B wing and C wing. May I leave the school now? Thank you.
My next example. Cos 540 is 360 plus what? So what can I reset my function to? Cos 1, 80. And one more. Sine 390 is equal to sine 360 plus 30. So I can reset to sine 30 degrees. Now tomorrow we are going to look at some special angles, okay? For now we are only going to focus on 90, 180, 270 and 360, but we're also going to look at 30, 60 and 45, because those always give us a special number.